Hey, what's up, folks? Welcome to the Sunday stream, or a Sunday stream. It could be multiple. It's possible. Yeah, we're doing some stream this morning, ipv6, finishing out that section. Isatap tunnel is the last lesson in the INE workbook, so we're going to give that a shot. Interesting developments here. It's been a few days. I know it's a stream. We've had what's been the weekend. Yesterday I was unable to stream. Friday's my day off, and then Thursday, I think was Valentine's Day. So anyway, we're here on a Sunday morning. I've already been labbing. Actually, I've already been studying since I got up this morning. So been making good progress. Worked a lot though. Yesterday in the, well, a couple things have been happening. One, I worked a lot yesterday on flashcards because what's happening is I'm coming towards the end of a section of the INE workbook. And I want to pull that workbook up. We'll keep the music going, by the way, this morning, folks. Let me know if it's obnoxious or annoying. But yeah, let's pull up the workbook and you will see kind of where I'm at. So we're started this beginning of February, I believe. I started the ipv6 section and I've just pretty much flown through it. Haven't had really too many issues. A couple spots where I got hit was, of course, multicast. I had to sort of pause there and catch my breath and take a little extra time. Also on, yeah, ipv6 PIM and MLD, PIM BSR, embedded RP, new concept, SSM. Also tunneling. So tunneling's gone well. You know, I really enjoy ipv6. And I got that one done, not too many problems. Then we got to automatic 6-to-4 tunneling and hit the skids a little bit. I was having a little trouble. I mean, you know when you understand or don't understand. Like I got through the lab. Struggled, but I got through it. I looked at the lab key. Okay, we got it. I can check the box because, you know, when you click on a lab, it goes into all the details in the workbook, and then you can check the box for your own purposes, right? I couldn't check the box. I'm like, you know what? I need to review this again. So I reviewed it some more. I reviewed it again. I did the lab again early this morning, and it was like, got it. Hey, we got a new follow. Sayajin 111. Thank you so much for follow. Enjoy hanging out here with us in the channel. Little networking, doing some networking good bits, discarding all malformed bits here in the Land Tamer stream. But yeah, I did. I'm in the ipv6 section, right? And the automatic 6-to-4 tunneling is actually pretty cool. And now I understand it so much better. This kind of falls in the category of one of the things I probably should have labbed more preparing for the written, because I would have been better. Now, I mean, I think I did pretty well on this section on ipv6 tunneling in general in the last written exam anyway, but in the prior attempts, if I had labbed this a little more, labbing was what really taught me. Like that was a teaching moment. So I got it. I was like, okay, this is really cool. And as a matter of fact, I went a little above and beyond. What I did this morning was I decided, okay, I'm going to diverge. I'm going to make my own lab. Well, I'm going to use the INE topology, but instead of routers 5 and 8, I'm going to do a segment because with 6-to-4 tunneling, with automatic 6-to-4 tunneling, the whole idea is that you can dynamically, you know, tunnel over a multi-access network. So router 5 and 8 are sort of point to point. And I thought, well, let me do 3 routers on the same segment and create 6-to-4 tunnels between all 3. And the cool thing is you don't have to have a tunnel destination. That's the beauty of it. You can scale it. So you don't have to have a tunnel destination. You just have to have a tunnel source. The destination is calculated automatically based on the IPv4 underlay network. And I don't know, it's just really cool. It's like, okay, boom, I got it. That's awesome. Let me see if I got any captures, come to think of it. By the way, folks, all these captures that I create, my library is growing, are out on GitHub in this link. But I think I got some, yeah, I do, automatic 6 to 4. I think this is router 5 and 8, but that's fine. Netizen 47, it's been a long time. Couldn't catch your shirt. No problem, man. I completely understand. And you know what? There's a lot of other folks' streams who I follow, but I don't catch, which I need to mention that, by the way. You bring up a good point. Community contacts and shout outs. There's a couple people I want to shout out to who have reached out to me regarding theirs. I've been helping sort of some newcomers to the scene of streaming / content creation out on YouTube. Let's say YouTube and YouTube. And you know, I haven't been able to look at their videos. Not all of them. I've watched a few of them. But again, why? Because again, they're more geared towards other certs. So yeah, it's a constant struggle to keep up, Netizen, on when you're creating content. You also want to consume the content of others, you know, and it's create versus consume. That is constantly a battle for me. No man's an island, right? So yes, I have been consuming, but I'm very selective and my time is very limited. All right, I do have a packet capture here for 6 to 4 tunneling. I've realized though that it's not really going to look much different from any other tunnel. Let me just see, because we've got IPv4. I need to clean this up. Yeah, you understand, Netizen. I think most people in our field do, right? There's that constant battle we all have of what do we focus on versus what other things are we trying to learn, right? CCIE versus cloud. I mean, just that is, it's a struggle. Constant struggle throughout, and it doesn't end. Throughout life, we have that those decisions to make. So, but yeah, if you look at a packet here, this is a ping, and it is flowing across our 6 to 4 tunnel, automatic 6 to 4 tunnel. First of all, there's no real way to tell that this is automatic. I don't know that you could tell looking at on the wire, to be honest. And on the wire, you don't really care, right? But you have your source and your destination of your IPv4 packet. And the IPv4 packet, of course, is going to be protocol 41. It means I'm carrying IPv6 as a payload. And if you look in the IPv6 packet, this is just a ICMP packet, type 58. Oh, you do see information here. This is cool. Now, is this part of the IPv6 header? No, this is Wireshark. And I think that, isn't that what the, that's a brace, right? I always forget what those are called. Googling it now. So yeah. That's a bracket. Shoot, I got it wrong. I always get them mixed up. All right, you know what? I'm going to make a flashcard. I'm already making flashcards here. Let me finish this one up. And I'll get back to, I promise, I'll get back to my agenda. Calc. Yeah, I thought so. Okay. New flashcard. These symbols are called, this is probably not related to the lab exam, but I gotta put these, throw these in somewhere. Square brackets. I've been making a lot of flashcards lately. This is Anki, by the way. And then these symbols referred to as braces. Okay. Anyway, so yeah, this is Wireshark information. This is not information contained in the packet itself. It is, there's a way to turn that off too, I'm sure. We get a regular ping packet. So yeah, there's no real way to tell. I still like to label them anyway. Oh, we don't need that. So I'm just going to include a couple of these examples. Yeah, just 2 packets. And this is called ipv6 6 to 4 tunnel. I'm having a little bit of a naming crisis with my packet captures. They've grown to the point where I need a little more bit of a formal naming structure here. Okay, automatic. I'm also trying to keep them very, yeah, see, we've got tunneling. Okay, here's 6 to 4. Let me look at that one. That was back in November. Does this show the same thing? Source. 6 to 4 gateway IPv4. I like that. Okay, we've already got that, so it's there. Anyway, went over that, like, okay, I got this. This works. What I call a comprehension delay or comprehension wall. That is now fixed, and I fixed it via labbing in this case. I also found that when you are doing, so a lot of these tunneling techniques, you have to take an IPv4 address and convert it from decimal to hex. And I figured out very quickly that I need more practice doing that. So I've included, I created a bunch of new flashcards. First thing I did is I went into Excel and I just created a chart. Basically, these are all the conversions I need to be able to do faster in my head, right? Oh, that's cool. I didn't know that. So I just went 16, 32, and use this autofill. So if you do this, this is a cool feature of Excel I did not know about until now. I figured it existed, but you can do decimal to binary, decimal to hex. And I just did this. And you can also do like hex to binary, which is cool. So I made this chart here. I'm like, okay, I need to be able to go from any one of these to either one of these relatively quickly. So I added a bunch of flashcards, like what is, if you have this in binary, what is it in hex? So in the next number of days, I'm going to be working on that for sure. The other thing regarding flashcards is I knew I was coming to a new section. The reason I didn't really stream yesterday is I mostly was just reviewing flashcards. I didn't feel I needed to stream that, although I've done that in the past. But I mean, I let a few days go by. The way the Anki flashcard algorithm works is it's based on time. So it reviews based on length of time when you entered the card, how many times you reviewed it, how you marked it after the last time you reviewed the information. You know, did you ace it or did you not? You need to work on it. And so it changes the frequency of how often you need to review those cards. And it also assumes a certain amount of time a day to review. But if you skip a day, it will just add on. So I had let a number of days go by because I've been just labbing. And so yesterday I got caught up. Like it took quite a bit of time, but I got caught up on all the flashcard reviews. And then today I created a bunch more flashcards. So anyway, the other thing it does is it knows when it's a new card or not and changes the review frequency accordingly. And then QS kickoff, yeah, I want to be careful about pacing because what I mean by that is my strategy all along has been to pretty much try to hit a section a month. This was January, multicast. I got through that late. I finished it in February, early February. Then I hit IPv6 and I just cruised through this. My idea was to start QoS in March, so obviously I'm going to be way early. There's a couple of approaches to that. One could be, all right, well, I could just take like a lot more time on labbing, like do more research, go a little deeper down a rabbit hole, rabbit holes, dig a little deeper. Or I can sort of keep the same pace and just keep going, as fast as I can. Not too fast. That's the other problem with that is when I set a time, box, quote unquote, on a section, if I knew I had a month just to study QoS, man, I would go somewhat deep. I would make sure I had everything before I moved on. So I'm kind of weighing that right now. Obviously, I want to get through with all this stuff and as quickly as possible, but you got to pace your learning because that's the whole point, right? Anyway, those are my thoughts on that. A couple of community contacts and shout outs. I've had a couple of people reach out to me. This has always been the case. I'll get a direct message on Twitter. I'll get a direct message or comments in YouTube. I mean, I'll get messages on Instagram. People will send me emails, which is great. I mean, I like interacting with the community. That's obviously what this channel is all about. And I've gotten a couple where people have really said, they appreciate the channel or the YouTube videos, and I always appreciate those comments, right? And sometimes it's people who are also trying to get started. I wanted to call out one person whose YouTube channel started recently, but he's been very active. Like I've seen some people start and then they'll fizzle out, which happens. I understand. But this person has been doing really well. And it's Safari. Let me go into Chrome. And just definitely want to encourage everyone to check out his channel and give him some encouragement there. That little sound is my alarm to like stand up for posture. I'm going to do that in a second. So let me just call out his channel and encourage you to check it out. Go to my YouTube subscriptions here. Man, we're coming up on, okay, yeah, Adam from the Future is this channel. Day 14, man. He's been pretty much every day. So definitely check out his channel. I'm going to give you a share here in a sec. I really like his logo. It's pretty cool. Let's see. Pardon me. Just take a moment. There we go. So yeah, this is Adams from the Future channel. Definitely check it out. Subscribe to him on YouTube. He's doing there's more around the security, and he's vlogging now too, which is great. So yeah, definitely show him some love and give him some support there. Adam from. So, isatap. I was just reviewing isatap and made a few cards for it. And the general idea that we're going to do of the lab that we're about to do is, let me pull up Versus Studio Code. Well, I've got it up, but let me make some notes here. So you're going to have a head-end router running isatap interface. You know, this is kind of like upstream, right? And then you'll have a number of host devices. Could be routers. Don't have to be, though. Who are downstream. And isatap interfaces. And the idea of isatap is intra-site. Let's see, what does it stand for again? Intra-site. I'm going to have to look it up. I forget what the acronym stands for. Intra-site automatic tunnel addressing protocol. I'm going to add that too as a flashcard. I know it's... sometimes it helps, though, in an exam when you're going through so many different acronyms. If you can remember what it is, what it means, it might help your brain click, oh yeah, this is how I configure that, right? Intra-site automatic tunnel. And this is under tunneling. I'm going to keep this guy over here. So I think in this case, for this lab, it's going to be... It doesn't really specify. So many acronyms, and that is, and as a matter of fact, I have in my notes repo, I have a bunch of them that I struggle with. I should actually add isatap to this. Intra-site automatic tunneling tunnel addressing. Okay, they could actually both be a router and a host. This lab doesn't really say. By the way, standard disclaimer, these are not my labs that I'm doing here. I'm doing them from the INE workbook, which I do not show on screen, but you can, there's a link below where you can purchase it yourself. You can see the full workbook. You can see the answers, screenshots, explanations, etc., right? I think in this case, though, what it's saying is R5 and R8. So what we're going to have is basically we're going to have ipv6 interface, right? Router. And ipv4 as sort of the we'll call it an underlay. R6 and the ipv6 interface. And the 6 interface will map to the ipv4 interface, right? I think we'll make, or this should be router 8. I think we're going to make router 8 the head-end router. Okay, configure isatap tunnel using their loopback 0 as source. Okay. So that would be loopback 0. So I think what we'll do on router 8 is we're going to say, excuse me, I got my, oh, I was supposed to stand up. Moment. I'll be right back. Okay. We'll stretch in there. All right, so yeah, what we'll do here on router 8 is we're going to say interface L0. We need to know what is his IP. IPv4. No, that's not right. He will be the tunnel source. Let me check this other router configuration here. Yeah, we don't actually have to calculate tunnel source. Okay, yeah. Let's see. Interface T100. Oh, let me put the rest of the requirements up here before I get too far. Use L0 source. Use /64 prefix. To allocate to tunnel endpoints. So the head-end router is going to do this, right? Create additional interfaces. With 2001.10 y. Use static routing to obtain full connectivity. Okay, this is really going to be icing on the cake. So our main configuration is basically composed of these requirements. So you need a tunnel source. You need a tunnel destination. Oh, you don't need a destination. That's right. No, take that back. You do. That was the thing about automatic 6-to-4 tunneling. You have a dynamic tunneling process like that, then you don't need the destination, right? It's determined automatically. Looks like with isatap, that is not the case, right? So we need a tunnel source, tunnel destination. We also need ipv6 address on the tunnel interface. So let's just do it here. Interface T100, ipv6 address. It wants us to use 2001.1058. The address is composed yeah, I think we have to use UE64 here because the first 64 bits is the prefix. And if we want to be able to use the underlay, the last... Oh, I have to do this, don't I? How do I indicate that this is... isatap address? Yeah, I think that's all. I think that's all. We just need the prefix. We just need the prefix here. This is the prefix we'll use on the tunnel interface, the tunnel overlay, right? So we got our underlay, which is IPv4, and then our overlay is addressed with this prefix. And I need I'm the head-end router, so I need to configure my own IPv6 address. I don't think this matters what the last yeah, I don't think this matters what the interface identifier is. I could actually put : 1 here if I wanted to. But I'm going to use UV64, and then I'm going to do tunnel destination, or tunnel source. J0158, tunnel destination. We don't need this on the head end router. Yeah, we don't need this on the head end router that I can tell. We'll find out. And we'll say tunnel mode ipv6 IP isatap. But on this side, router 5. You know what? I've got network lessons here as sort of an example, but I should use Cisco documentation too, because that I can show on the screen. Let's see if we can find. I'm going to try not to get triggered here. Yes, I am opening Cisco documentation, and hopefully I don't get triggered. IPv6 library. This has been really... These two links are bogus. Colonel Panic, good day. Recently found your stream and YouTube videos helping me through IPv4 multicast. Oh, that's great, man. Welcome to the channel. Glad to have you in here to talk about some good bits, good networking bits. Glad the content has helped. Very glad about that. That did not yield too much. Let's go to VPN. Maybe it's under, oh, you know what? It might be under protocol independent or interface. I'll bet you it's interface. IP over IPv6 tunnels. Yep, I knew that. Automatic 6-4 tunnels. Isotap. Here we go. Yeah, these run dual stack, of course, but your hosts only need. So good. It's got some good information in here. Yep. Here's the 64 bits, 32 bits. Yeah, we have to do this. It is saying that's optional, UE64. So this is our head end. And what we're going to do is instead of so we are going to advertise. We want the other router to use this prefix, the host to use this prefix. So that's why we want to send a router advertisement here on router 8. And over here, we want to do IPv6 in the auto config. Tunnel source, tunnel mode. Now this will need a tunnel destination. And for my example, now this is showing the head end. Yeah, there is no destination here. It does not show the host. Of course, the host in most cases is going to be likely be a Windows machine or a Linux machine, right? Overlay. Yeah, you get IPv4 compatible, GRE, manual, 6-4, and isotap. Must point interface with IPv4. The address and prefix are configured as for a native IPv6 interface. Oh, the IPv6 tunnel must be configured with a modified because the last 32 bits are constructed using the IPv4 tunnel source address. Okay. Tunnel mode, tunnel source. Okay. Okay. specifies interface assigned to the interface enables IPv6 processing on the interface. Sending a IPv6 router is disabled by default on tunnel interfaces. This command and it re-enables, right? So yeah, I just want on the other end to be client. And it's saying here in my network lessons example, that I need to use the tunnel destination is 151.58.8, the IPv4 address. Okay, so it sounds like what it's going to do is it's going to obtain it. It will obtain its prefix through ND autoconfig. That will be its IPv6 address. And then when it creates the payload, so I'm thinking now about the router, right? So I'm the router, and I'm going to, I bring up this interface. I'll obtain an IPv6 router as host, 6 address prefix, and append my interface identifier to it. Then when I send a packet to the remote IPv6 destination, what's going to happen is the we have to be able to route to it, right? So that's actually, we'll do that also on each router. We'll configure a static default route because it doesn't support multicast, doesn't support dynamic routing. So I have to say IPv6 route, and we'll just say : 0. Just use a default route. And the next hop will be tunnel 100. So basically it's going to do a lookup. It's going to say, okay, how do I reach that remote address? It'll recurse and it'll say, okay, tunnel 100. And it's going to know that the destination in IPv4 is this. So the question is, will it know automatically the, okay, so it will put the destination, it will create a IPv6 payload packet, and the source is our own IPv6 address, destination, remote IPv6 address, and then it will and then it will hit the tunnel interface and it will know it needs to encapsulate that, right? Tunnel interface will encapsulate due to the IPv6 IP isatap command, right? That's the type of tunnel it is, so that tells it what type of encapsulation to use. So what it's going to do is now it has to do the source IPv4 source address, which is going to be the address here, right? 151.58.5, and it knows, okay, the destination address for encapsulation is that. Okay, IPv4 destination address, because it's specified here. All right. And then it will be forwarded out that interface. It'll come in on the other interface. It will be, the router will know that the destination is itself. So process the packet. It will know that it came in it will it will process it, and then it'll look at the payload and see this is an IPv6 address with the source as router 5's and the destination as our own. In this case, it'll be our own, right? And then it will peel off to look at the IPv6 payload. After it looks at the IPv6 header, you'll see that it's an ICMP ping, and it will send a reply. All right, I think we got this. Let's see, what else are the requirements? It also has a requirement here. Let's do this part first. Make sure this works. So router 8, I'm using my Azure lab this morning, the big boy. I do want to wrap up for lunch. I'm going to take it at noon. We're going to... Oh, I have to allow pop-ups on this new IP address. I'm considering moving to a dynamic IP. It's a little more a month, but I had some funds to spare this month. My Visual Studio subscription refactors today, and I've got like $18 left on it, so I'm doing good. And we're going to allow that way. I won't have to do this each time. So, and we may do that. As a matter of fact, would you like to see how that is done? If we go to this virtual machine, all we have to do is, almost 19 bucks remaining. So, let's try it. See how it goes. I was wondering, so yes, please. Yeah, so in Azure, you have these network interfaces, and actually, I think I can just click. We already have what's called a PIP, a public IP address, which is its own entity, and we can change it to static. So that's how we would do it. Also have a network security group. Which I'm allowing only my public IP access to it. I have a permanent DNS name, but the problem is with the Mac. Specs of the VM. Good question. Yeah, I actually have a command for that. I get asked that a lot. I don't remember what it is at the moment. Oh, I even have the acronyms. Okay. Oh, here you go. It's actually part of cost. This is a beefy machine. I'm thinking about toning it down, because unless you have a Visual Studio account, would not necessarily recommend this, because it's big. I have one that is bigger than this, that has 20 vCPUs and 128 gig of RAM, but it's way overkill. But I have some pretty big labs. Like I've had labs with up to 70 routers in them, just for fun. But let's do this configuration here on router 8. Yeah, I'll do that after, because I don't want to reboot at the moment. Tunnel is up, router 8. That went smashing. Let's go router 5. Tunnel destination cannot be, okay. Interface T100. This could be, I mean, maybe this is a limitation of the code. I don't know. Let's see. No? On network lessons, they were able to do this. Tunnel mode, IPv6 IP, isatap, yeah. And then tunnel destination. Tunnel that fail on the be configured. Tunnel that cannot be configured under existing mode. Really? Okay. Well, let me just leave it blank. Maybe it, let's see. Let's see what happens. Oh, I see what it is. The example I have in network lessons, they're doing, it's doing something else. Yeah. No tunnel destination. You don't use a tunnel destination. But the whole thing here, the requirement is I want to use this 64. So I could have assigned this statically on both sides, or I just could have made this a router advertisement. So we don't need that. Okay, use static routing to obtain full connectivity, which we've done. So let's see if we can ping across the tunnel. Show ipv6 address. First of all, let's see if we obtained an ipv6 address using ND auto config. And look at that, we have, I think, wait, tunnel. Okay, 2001.5.1.1.2.3.4::5. Is that right? Oh yeah, it is 155.1.58. 155.1. 1, 2, 3, 4. Is that the, what's our ND auto config? No, it should be 2001.058. Oh, tunnel 100. It did not get one. Okay, I'm looking at the wrong tunnel. All right, so it's unassigned. So that did not work. Oh, I know why. ipv6 auto config. ND auto config. Prefix. There we go. So that's I forgot, or I didn't put the right command in here. That's why I didn't have it in there. So no destination. Okay, so let's see if we got an address now. We do not. We do not have an address. He has one, 2001.1058, yes. And we see 5EFE, 9B01.3808. That looks right. So let's see router 5. Let's just do that. Yeah, it's not getting one. All right. Well, we won't get too cute here. Let's just do this. So we'll manually assign. Show ipv6 interface brief. Okay. Show interface T100. Set of tunnels. Okay, good. Look at that, isatap. So now we should be able to ping the other side. Which is this address. Notice the link local address also converted to an isatap address. Nice, works. Let's get a PCAP of that. Then we'll get a little fancy and we'll add new networks that we can route to using our newly formed isatap tunnel. That happens sometimes. Let's try it again. There we go. We'll do another ping. Now we're running RIP. Interesting. And there we have it, folks. So here we have IPv4. It's going to be protocol 41. Jorson, thank you for that subscription. Thank you very much. I really appreciate that. Appreciate the support of the stream. Enjoy your new emote. We have a Good Bits emote. It's all we got so far. But thank you so much for that. As always, Prime sub. And really appreciate it. Thank you very much, Jorson. I don't know if I'm saying that right. Jorson. But thank you very much for the support again. As always, appreciate you all hanging out in the chat as well. That is awesome. All right, so here's our source, folks. You see the source address, destination, and it recognizes, Wireshark recognizes this is isatap. I think I already have a sample for this. Let me look. Do I have isatap in here? I do. Yep. Good. And all we have to do, again, we have a static default route. So we can add additional interfaces over here. L1, we're going to say, let's see, the requirements are create additional loopbacks with this and use static routing. This static routing should work. And this will be 8. And we'll go to router 5. Basically now router 5 and router 8, you know, any IPv6 address they're going to try to reach, even though they're going over an IPv4 cloud, right? Any IPv6 address they're going to try to reach, because I'm using a static default route, it's going to go over that tunnel and should be able to communicate now. So we're going to say interface L1, IPv6 address, and this will be 5 and 5. So now ping 2001 1088, and this should work. Show IPv6 interface brief. 1058, yeah. 108::8. Yeah, should be able to reach that. Not sure why that's not working. Use static routing. Show IPv6. Yeah, I'm saying this is a static default route. I wonder though, it does not say. Gateway of last resort, right? All right, let me check the workbook to be sure. Oh, it wanted to use that as the tunnel source. Interesting. Yeah, that's different from my network lessons example. So is it only going to route to your source? Let's see. So our tunnel source in this case, run interface T100, is GI0158, show ipv6 interface brief. So it's saying this. So I wonder if I can reach that over the tunnel. Ping 2001 151 58 8. Ah, okay. So it is limited. It's saying basically boy, that doesn't really scale well at all, does it? When configuring, you can automatically generate. Oh, isatap tunnels cannot automatically extract the destination. Ah, that's the problem. So the default, the route, you have to have specific routes. That's the issue. I didn't know that. So you cannot use a default route like you can in 6 to 4. So let's do this. Well, no, this is working though. Yeah, I'm not sure I follow that. All right, we're going to spend a little more time on this. It is my lunchtime, though, so I'm going to grab some lunch, and then later this afternoon, folks, I will come back, continue this. As always, of course, I will post these on YouTube. So if you happen to miss me this afternoon and want to continue looking at what came of this lab, again, we've got connectivity. I just need to understand the differences between Auto 6 to 4 and how the routing is working, because yeah, obviously we've got some differences here that I need to make sure I understand. So thanks so much for hanging out, folks. As always, appreciate the support, and we'll be back here soon. I will post, if you're not following us yet on the Discord, check out the Discord channel, and let me see if Dmitry is up yet. We could host him, but I think normally he starts at 12:30. Let me check, though, and see who else might be streaming. No, he's not live yet, but folks, he will be up soon. As a matter of fact, Dmitry has his own command. If you want to watch some more labs here, he does network programmability labs. So he'll be on, I think, at 12:30 today, and I forget what he's covering, but he's covering a different module today. So what I'm going to do here is I'm going to wipe all nodes. We're just going to shut her down. And I'm going to change the, I think I'll go ahead and change the static from dynamic to static IP real quick. Stop nodes. Did I do that? I think I did. So first though, we'll close the lab down. And go back up into Azure. Go to the VM. We'll try it. I'll see what the cost is. This is a good time to do it because, by the way, I think I can do this with the machine stopped. So we'll stop the VM. Networking. I find it interesting. It's almost as if like a timer was set. I find it interesting that the Microsoft just seems to have IPs to hand out, you know. Must be nice. Yes, that is fine. Save. And it's done. So that's all there is to it, folks. They just charge you more for a static IP versus obviously a dynamic, just like a regular ISP would. Also, you can do static. Well, no, I think they only issue dynamic IPv6 addresses. That could be different now because Microsoft changes, you know, in the cloud. Like things change every day. They're adding new features. So that could be different, but anyway, that's going to wrap it up now for folks. For now, folks, thanks so much for tuning in. Appreciate it. Appreciate the support. And we shall see you back here later this afternoon in LAN Tamer Stream. You can follow me on Twitter, Instagram, YouTube, and of course here. Thanks again for the support. They're the new sub. Appreciate that. And folks in the chat, we'll see you back here soon. Have a great rest of your Sunday. Evening, we're back. I've actually been working on this all afternoon. Well, most of the afternoon. Went out to lunch. We kind of had a post-Valentine's Day, sort of actual Valentine's Day sort of date, which was nice. Scheduling worked out better for us to do the weekend. So anyway, had some lunch, came back, started working on this. And it's been a struggle, man. It's been like one bout after the other with IPv6 tunneling. It was funny. I thought at the end of doing automatic 6-to-4 tunneling lab that I thought I sort of had it. And then I worked on the isatap lab and it scrambled like everything. You know, my weak foundation, the foundation I thought I had was weak, and the storm came in and just blew it down. So I had to go back and start working on this again. But I think I'm almost there. You know, I had intended, I thought I was just going to breeze through this tunneling lab. So like, I got this. I'll be able to start QoS yesterday. But it hasn't happened, and that's okay. We just gotta, we really need to understand the differences in these tunneling technologies and how they work. And at their core, and I'm going to try to explain it. I'm hoping this will help me. There's one more piece left that I'm stuck on with isatap. So I started this drawing to kind of help me out. And here is, okay, lab is booting up here. We're going to lab the isatap again. Can't tell you how many times I've labbed each of these, to be honest. Hey, this time we're going to have a static IP, which is going to be awesome. We'll see how much it costs. Casadix, how are you, man? Good to see you. Hope you're having a good weekend, bud. Hope your weekend is going well. Mine's been pretty good, I have to say. Yeah, I'm going to clone this thing because I want to save these. I'm curious, did I save the labs I did? Now, previously when I was studying for the written, okay, I did not. Yeah, I didn't save these tunneling labs, so I'm going to do that now. I'm actually going to, this is INE, we're going to clone from ipv6 initial, because I want to save these bad boys. So we're going to say ipv6 tunneling isatap. And we're going to open this one and use it. Okay, we're going to launch router 5 and router 8. So here's the thing, like, I'm just going to read through this and see, read it out loud. Maybe it'll make a little more sense. But 6 to 4 tunnels. And I thought, you know, I have a spreadsheet where I was kind of making columns, contrasting, and I don't know, that got a little out of hand. It was messy. It's not really what I want. So I'm doing this, right? 6 to 4. And let's make this a little bigger. Actually, yeah. Not the whole text, folks. Just that. 12? Yeah, 12 all around. So I'll make this bigger. Tunnel endpoints are on different subnets. They are, but they use the same prefix. So that's probably a better way to put this. So in 6 to 4, tunnel endpoints share a /48 prefix, but use different subnets per router. The reserved use prefix 2002 is 16 plus 32 bits. Okay. How did that happen? Don't know how these things happen. Let's see, a better way to enumerate this. Tunnel endpoints share 48. Yeah. Shared prefix is composed of 2016 plus 32 bits from IPv4. Oh, yeah. But 30 IPv4 link. There we go. That's really the best thing to say, right? So the IPv6 source address this goes better ahead of that one. So it is manually assigned. Actually, I should say IPv6 source trying to say this in a succinct and easy to digest method for myself and others. Tunnel endpoint share of /48 prefix. Actually, they don't. That is not a 100% true statement. So like this is 2002 9B01 colon 9201. This is 2002 9B01 colon 9206. Yeah. Okay. The best way to say this is tunnel endpoints use a /48 prefix. Let's see, what do they share? Tunnel endpoints share a prefix an IPv6 address that starts with 2002. Okay. That would be correct. Tunnel endpoints share an IPv6 that starts with 2002:/16. Endpoint prefix uses 2002 16 bits plus 32 bits from the IPv4 interface. Yeah, 32 bits from IPv4 address. That is correct. The IPv6 source address must match we'll say IPv6 source address must be manually configured. And IPv6 source address actually IPv6 source interface prefix must use how about IPv6 source prefix portion of prefix must match IPv4 of tunnel source interface. There we go. Okay. Can route to any IPv6 network with static routes. Actually, let's use this first. I think this is more significant. Routes to any destination using address derived from IPv4 interface known via routes to can route to IPv6 destination address derived from IPv4 address known from unicast from IPv4 routing. Okay. Can route to IPv6 destination address derived from address known from IPv4, or can route to any IPv6 network with static route using next hop tunnel address. There we go. It is common to set a default route at 2006 route a static route of or 2002.16 with tunnel interface as next hop. Okay, I think that says it. That's a good summary right there, I believe. Now, isatap. This is like a theory that you're trying to prove in science class. Okay, isatap, tunnel endpoints must be on the same IPv6. Yeah, well, if it's /64, they're going to know it's IPv6, right? Endpoints can use any routable okay, no restrictions on, I would say no. Oh, let's say endpoint prefix not limited to 2002:16. Can be any routable, yeah. IPv6 tunnel address interface identifier can be signed automatically. Okay, that's true. So we'll say, what does it say up here? Tunnel IPv6 source. Oh, IPv6 tunnel address identifier can be assigned automatically using UE64 option. That is true. IPv6 tunnel address interface identifier is derived from tunnel source interface IPv4 address. That is correct. Static routes. Now this is the part where I get fuzzy right here. Right here. Oh, I also have these notes, by the way. So if you do, because most of tunneling, right, is these 4 boxes. I think there's a way to, okay, that's cool. So you have IPv4 source, IPv4 destination, IPv6 source, IPv6 destination. Tunneling is all about filling this out and getting the payload to the next interface or router that needs it, right? So if you do a ping from, for example, router 6, if you do a ping to 2002.9b01.9201:1, which is router 1's tunnel interface, here's what happens. I get my IPv6 header is the tunnel interface address. So it's what I have configured here. Let's put this down here. This is turning into I don't know what, but anyway, it's going to help me later too when I come back and I'm like, what is this again? Okay, so IPv6 source is 2002.9b01.9206.6. IPv6 destination is in our ping, 2002.9b01.9201:1. We don't have support really here over the IPv6 interface, tunnel interfaces for multicast. So there's no neighbor discovery, right? We have to use some other scheme to determine, how to find out what is our IPv4 source and destination, right? So the source is always going to be the tunnel source IP address. And in this case, our tunnel source, GI0146. Now, what is our tunnel destination? In this case, it is derived from the next hop. I should put here IPv6 address. It is converted I know it's probably hard to see on stream, but converted from the IPv6 destination next hop IP address. So in most cases, it will be Let me think about this. So I'm curious how this works. How does this work if we have just, and now I'm going to have to go back and do this lab again, which is fine. So let's do router 4, router 6, and router 1. If I have a static route that says if I have a static route and this is a destination IPv6 address as the next hop, then this rule works. I convert the next hop IPv6. And in this case, we use our hexadecimal conversion. It goes to 155.146.1. But what if I do a default route to the tunnel interface? How does it recurse to the next hop route? That I do not know. It's kind of the same issue I'm having down here, but let's see. So we're going to load up the let's console into these bad boys. And let's check on our cost. Today's the day my $150 resets. So I want to see what time, because cost management, 1742 remaining, which is plenty for today. If this switches over, I'll know I'm on the new billing period. Nope, still in 217. Okay, that's cool. So router 1, what pop-up block. Okay, this will be cool. If I have a permanent IP, I should be able to console to all nodes now and not have to click on that anymore. Nice. Okay. So we will do interface T100, IPv6 address, and I don't remember. Actually, I know how to do this though. So we're going to do IPv6 general prefix 6 to 4, 6 to 4. We're going to use actually just for grins, let's do loopback 0. Just to scramble our brains a little more. So now I have to do show IPv6 general prefix. Okay, there's our address. Interface tunnel 100, IPv6 address 1002.9601.101. And we'll just do 1. This really doesn't matter, right? Tunnel source is loopback 0. And tunnel mode IPv6 IP 6 to 4. That's all we need. IPv6 general prefix 6 to 4, 6 to 4. Well, that's cool to calculate. 6 to 4, 6RD. There are two 6RDs here for some reason. Two 6 to 4s. Oh, no, there's just 6RD, 6 to 4. And L0. Oh, one problem I had previously is I noticed my loopbacks were not known My IPv4 loopbacks were not known by the other routers. Let's see if that's still the case. Ping 150.1.4.4. They're not, so we need to turn on EIGRP. Router EIGRP, fix this. Address, family IPv4 unicast, autonomous system 100, network 150.1.1.1, and 155.1.146.0. Yeah. That cost me some time in a previous lab. I was like, oh, well, I loaded up this lab. And again, this is, I'm not going to rant too much today, I promise, but this is just a sloppy, like, lab setup that they have for this little corner of the workbook for some reason. Let's do router EIGRP, fix this. Address, family, IPv4 uni, autonomous system 100. Network 150.1.4.4. Zero 0.0.0.25. Yeah. Show IP interface brief. Are the interfaces up? I found in some cases that they were down for some reason. Folks, you've got me. I'm not sure. Okay, that one is up, so that's good. Router 6. Router EIGRP, fix this. Address, family, IPv4 uni, autonomous system 100. Okay, and show, okay, we got a JSON, good. So that interface is up. Show IP EIGRP neighbors. Okay, I'm not sure why that is. Oh, I did shut. I needed to know shut. There we go. Okay, so now ping 150.1.1.1. Good. Now we can continue our tunnel. Six address is do show IPv6 general prefix. IPv6 address 2002.9601.404. And IP tunnel source loopback 0. Tunnel mode IPv6 IP 6 to 4. Tunnel is up. Let's see, IPv6 general prefix. Do show IPv6 general prefix. Interface T100, IPv6 address 2002.9601.606. 6. Tunnel source is loopback 0, and tunnel mode IPv6 IP, and 6 to 4. Okay, we should now be able to reach the other side. So here's a question. Here's what I want to see. First of all, I want to turn off neighbor discovery. Or I should say router advertisements, right? So what I'm going to do here is I'm going to shut down any interfaces we're not using for this lab. 0167, shut. And that's it. And then we're going to say on, I don't want to see any neighbor advertisements or router advertisements. So on interface GI0 1146, say IPv6 ND, or no, RA, NDRA, suppress. So we should have no neighbor advertisements, or router advertisements. I keep saying that. I'm going to do the same over here. We're going to shut down that interface, and okay, good. All right, we're going to say now on interface GI01146, no IPv6 ND RA suppress. Actually, we want IPv6, sorry, ND RA suppress. Wrong command. And then we're going to do the same router 6. Oh, we did router 6. Show IPv6 interface brief. Yeah, show run interface 0146. Okay, suppress is on there. I know it's on there. And show run interface 0146. Okay, it's on there as well. So we should not see any router advertisements. Let's do some sniffing on router 6. And this is cool. This will speed this up because I'll only have to do this once. Nice. Okay. You know, I'm making this too hard, I think. So let's go back. So if I ping this IPv6 address, we should be fine, actually. Because what it will do yeah, okay. This is fine. This is fine. What it will do is it will say, okay, my IPv6 destination is this. So my IPv4 destination will be, we're going to convert these 32 bits, and that becomes your 151.146.1. That becomes your IPv4 destination. That's right. I don't know why I was making that so hard. And that's cool. That's what I had gotten to before. So, but I don't think I needed to do this lab. Yeah, so that's the beauty of it, right? Because you don't have neighbor discovery over the tunnel. You have to use some other sort of formula to figure out, okay, what is our destination, right? And the underlay network, it's not Ethernet here, it's IPv4. So we figured that out. All right, so down here, isatap, static routes must be used for each destination with full next hop router IPv6 address. Okay, I understand this now, I think. I think I've got it. So here's the issue. Let's copy this. Okay, I think I have it. See, the thing is we don't have to have a specific route to this destination in an IPv6 route. Because again, the destination always has to match it needs to match an IPv4 address that we can convert it to. Even if we can create static routes. Let's say we have a 2003 address here, like a loopback 1003. 2003, that's fine. We can still get there, but we have to create a static route with this guy as the next hop. And then we just recurse to this, which gives us our IPv4 destination, and the packet gets there. However, down here, we're not using the same rule about who would be the next hop router for that destination. And there's no real way that I can derive that. So I have to have a static route here. What I'm not sure about is, and this is what I want to lab next, is I don't know why I can't have like a default route. Let's see. All right, we're going to figure this out. So let's say we want to ping 2001 101 : 1, and that's over here. Let's say that's an interface off of router 1. The source address is going to be our interface tunnel address. So it's going to be 2001 1058 : and then it's going to be our UE64 interface address, right? That's going to be our IPv6 source address. Our destination address is what we're trying to ping. Or HTTP traffic, whatever the case may be, right? Our IPv source is always going to be, that's easy. It's going to be the IPv4 address of our tunnel source interface. So same. Our tunnel destination, we cannot convert it from this. So the only way we can know that destination is if we have to have a specific static route with the next hop. So we're going to have, and I'm going to put this here. Maybe that'll be helpful. We say IPv6 route 2001 101, and then the next hop is going to be 2001 1058 1. And that should work because we know that this is the same prefix as what we're using on our tunnel interface. And we should be able to convert that back to an IP address. So actually this would be, for example, let's do these the same. But the prefix we're not limited to. It could be any. Wait a second. Now this is. Okay, yeah, this is different. So we're going to put here, we have to tell it's either router 1 or router 4, right? So what we're saying here is this is going to be, well, we'll do this, that's fine. 0, 2001, 1058. UE64 of router 1. There we go. So we will be able to derive the IPv4 destination because the next hop is on our same subnet, so we know it's a tunnel address. So we know we can convert it, right? The conversion is going to work on this IPv6 address because it's on our same subnet. Okay, I think that's got it right there. And these remote routes can also be learned via, like, let's say we're in a situation where you can't have a remote router that's not on our same segment. You know, I'm not even going to, I don't think I can explain that right now, to be honest. But we'll just go with this for now. So that should work. Okay, yeah, this can be derived from IPv6 desktop address only because it's on same subnet. So conversion will work. There we go. I think I've got it. All right, so let's go back. I didn't really need to do this lab. So what I'll do is close this and we'll redo the isatap lab real quick. That is going to be, let's see. Actually, I'll save this, right? I didn't put the default route on there, but that's okay. Actually, let's edit that now. So router 1. Don't know where that should go, but we'll just put it at the end. ipv6 route 1002 tunnel 100. Yeah. Save. And we'll put that here as well. And router 6. Okay, and I'm gonna put this in the notes. Close lab. Oh, this says isatap, doesn't it? That was our intention. We're gonna do IPv6 tunneling. 6 to 4 automatic. And we're gonna say in the description, this lab utilizes R1, R4, R6 segment, not the same one from the ID lab. Okay, good. And then we're going to duplicate this. We're going to clone it. We're going to say IPv6 tunneling isatap. Open this. We're going to wipe all nodes just in case. And we'll start routers. I think this one is router 5 and router 8. Yeah. Yeah, where I was getting stuck before is how does it figure out if you give it a next hop here, if you create a static route and say this is the next hop, without neighbor discovery, how does it know what IPv4 address that is? And the way it does it is it's like, well, this we're on the same segment. We know this is isatap address, so we can convert this address to get our IPv4 destination. I'm pretty sure that's how it works. I haven't seen that written anywhere, but I think we're about to confirm that now, and then we'll be good with this portion of the workbook. I think. I know I've said that before, but hey, it's all. I didn't want to move on without knowing that I understood the process. You know, gotta understand the process. Otherwise, what have you accomplished by labbing anything or right? Okay, so I'm just going to go straight from the workbook here. Let's see. I was determined though, like I wasn't planning on streaming again. I was just going to do some more studying. I'm like, I've got to get this down. I haven't eaten dinner yet. I'm going to eat dinner as soon as I finish this, but I'm like, I want to choke it to the ground, you know, till it clicks. And I think we've got it, because it's hard to come back, right? It's when you think you're at the precipice, you've climbed the mountain and you're almost at the top. It's not the fairest of, you know, analogies, but you at least, to take a break, when you take a break, you go back down the mountain. Sometimes you fall down the mountain. Then you got to climb a little ways back up to get to that point you were at before, and then get to the top, right? So that's why I was trying to just lock this down. All right, so you know, it's actually very simplistic when I think about it. We're going to do interface T58, IPv6 address. And this is even easier because you don't have to do a prefix. You don't have to calculate tunnel source loopback 0. Tunnel mode IPv6 IP isatap. Interface L58 IPv6 address. Again, we're just going to do a global address here, 105. And we're going to say, oh, this is interesting. Yeah. IPv6 route. It's almost like a default route. In this case, it might be the way to go, right? IPv6 route is a static route, but the difference here is we can't just point to the tunnel interface. Because the destination is not going to give us the converted IPv4 destination. So we have to do it here. We have to say it is 2001-1058-05-EFE-9601-808. So in other words, if we looked over here, then we'll see it in a second. Interface T58, IPv6 address, UE64. I can do show IPv6. That feeling, Kasadik says, that feeling to be too close to solve the puzzle, we can let it go. Yep. Do show IPv6 interface T58, and it gives us the full the UE. Yeah, this is it. So that's what should be over here. 2001-10580 5200 FFFE08. Oh, wait a second, that's different. Oh, that's the solicitor no multicast now. Global. This is different. That's the link local. This is the global. So I actually need to put this. Yeah, why am I doing what's in the workbook for this? Because this is based on the no, that should be correct. 5EFE-9601-808. See, IPv6 address 2001-1058, colon 64 UE64. This is right. Our concern here is the destination IPv4 address. And this should convert to the IPv4 address of loopback 0. In fact, let's confirm that. Show IPv interface L0. 150.188, right? So what if we do IPv6 general prefix test? And oh no, we can't really do that here, can we? Show IPv6 interface L0. Okay, so we have to manually figure out what the isatap address would be. Next hop router isatap. Next hop IP, or how we say it. Sometimes this is learned via DNS, isatap dot whatever, because it is kind of could be error prone, but IPv4 destination. See, IPv6 isatap address for IPv4 destination IP must be determined, must be calculated manually, or can be learned via DNS. There we go. That's the little bit of the tricky part, right? So we'll just assume that INE is telling us the right thing here, which it should be. We can do 96. We can do a quick conversion, right? 96 is, and I'm trying to learn these. That's calendar, calculator. Let's say 96 in hex. 150. Okay, 150.1.8.8. Yeah, and we have the 5 EFE. So that should work. Let's make sure we can ping that. We can. Okay, so over here on router 8, show run interface T58. IPv6, or no, tunnel source. L0, tunnel mode, IPv6 IP. Something I need to do too is I need to find examples of this in the Cisco docs in case I need it during the lab. Like I'll know where to go. And then interface L58 IPv6 address as a 1.1.0.8.8.64. Wait, is that right? Okay, yeah, that can be anything. It can be anything. And then IPv6 route 1001.16 1058.0.5 EFE 9601.505. $150.155. Okay. Now, our verification show interface T58. So we are using isatap, and the tunnel source is the loopback, which is what we want. Show IPv6 interface T58. Notice it does the link local as well. It converts, it tells you, actually that's helpful, isn't it? Well, no, that's just based on what we entered as a, oh, there it is. I could have just looked there to find it. All right. And now we should be able to ping Let's go to router 5. Yep, we got it. And that is the tunnel interface, tunnel 58. Now we should be able to ping that loopback 58, that new one that we created. Which is cool. And really, any network that is over here, IPv6 network that we're trying to connect to, we'll be able to connect to it as long as we have an appropriate static route pointing to the IPv6 destination next hop address that can be converted to the IPv4 address where it's supposed to go. So, all right, I think I got it. I think we're going to wrap up there today, folks. We're about to grab something to eat. It's been, I'm going to mark this one as checked. So tomorrow, we've got MQC classification and marking. QoS, yeah. So, better late than never, right? Thanks so much for hanging out, folks. We will see you back here tomorrow night, hopefully, 7 p.m. Eastern Time, if all goes well. Back here in the Land Tamer stream. Thanks so much for hanging out, chatting. You can follow me here, YouTube, Twitter, Instagram. And, of course, you can give me a follow here on Twitch or a sub if you have an Amazon Twitch Prime account sitting around that renews every 60 days. Would appreciate you using it here. So thanks so much. Have a good night, folks, and see you tomorrow.